are asked, if 60 degrees is the central angle of a circle, then the ratio of length of arc to the circumference of a circle is dash. So do you remember the formula that length of arc is always theta, the central angle, over 360 times 2 pi r. Do you remember? And we can say that theta, the central angle, is 60 degrees over 360 degrees times 2 pi r is the circumference of a circle. So this is length of arc. So we are asked to find the length of arc, the ratio of length of arc to the circumference. So bringing the circumference of the circle to this side. So we have length of arc over circumference of the circle is now 60 over 360. So which is 1. To find the perimeter of the shaded region. See the shaded region. And the shaded region has what? The length of arc and the hypotenuse, because this is 90 degrees, the hypotenuse of the triangle. So, and again, from this is an isosceles right triangle. This is R, means that AB must be R times root 2. R times root 2. By 45, 90 triangle 2. See, this is R, this is R, this is 90. Here should be 40 degrees. 40 degrees. So by 45, 90 triangle theory, the hypotenuse must be R root 2. And the length of arc, let's remember the formula for length of arc. So I'm saying that perimeter of the shaded region is length of arc AB plus AB, the hypotenuse, and length of arc is always theta. Our theta here is 90, as you can see, 90 degrees over 360 times 2 pi r, because the radius is r, plus AB is what? R times root 2. So our answer is so pi r over 2, because this is 4. 1 over 4 times 2 is 1 over 2 plus r root 2. So our answer is D. As two chords of length 24 cm and 80 are on opposite side of the circle of radius 15 cm. What is the separation distance between the two chords? Let's start by drawing the circle. And CD. So CD are the chords, opposite sides. This is the center of the circle. And they told us the radius is 15. So this is 15. This is also 15, 15, 15. They said the two chords of length 24 and 18. So AB is 18. But do you remember that if a line runs from the center, it always bisects the chords? It's a theorem. You have a line that runs from the center of the circle that is always perpendicular to the chords, and also bisects, is a perpendicular bisector. So I'm saying that, remember, there are 24 and 18, so meaning 1 is 9. 9. While the other one is 12, 12. The line that runs from the center is always a perpendicular bisector to the chords. So we'll form a right angle triangle, taking one part of it. Okay, let's name A, B, C, D. Let's name here E and F. So as you can see from this triangle, from triangle AEB, EO is always from Pythagorean theorem, square root 15 squared minus 9 squared, which is 12. For this 225 minus 81, 144 square root is 12. Again from here, triangle OFD. OF is also square root of 15 squared minus 12 squared. So as you can see, this is also 9, because this is 225 minus 144 is 81. Square root is 9. So we are asked to find EF, the separation distance. Therefore, EF equals EO plus OF, which is 12 plus 9. Our answer is 21. Option C. We are given the diagram. If PR is 8, so the tangent, as you can see, this is the tangent line, is 8, and PO is 6. PO, this is the center of the circle. So since this is the center, OP is the radius. The radius is 6. And you know the relationship between the radius of a circle and a tangent line, they're always perpendicular. So this must be 90 degrees. So let's finish up this. This is also the radius, because this is the center. This is 6. So we'll form a right angle triangle. So ROS is now, from ROS is now RO, that's the total, RO minus OS. And but RO, from Pythagorean theorem, RO, that's the hypotenuse of this right triangle, is always square root of 6 squared plus 8 squared. That's from Pythagorean theorem. So we have that is 10. So our answer is now, therefore RX is RO, which is 10 minus OS, which is 6. Our answer is option B.